everyone. So good morning, and this is going to be lecture number 18 on continuous random variable. So I believe you guys are following the lecture honestly. The amount of effort that I'm putting is very large, you can say, right? So my main objective is you should watch these sessions, okay, very honestly, and also keep notifying me that you have watched it, or you can also put your comment right after watching the session. You guys can put your comment that what you have learned. That should be the idea, because the future people will also come to know, okay, these are the things that you can learn from this video, right? So whatever is learning you get from each video, you can also comment, right? So this session is gonna be lecture number 18, right? Lecture number 18. And we are talking about continuous random variable, okay, and we have discussed about some of the basic density function. You can say that was uniform density function, simplest density function, uniform density function. Also I talked about piecewise uniform density function, right? As well as we have discussed about the how to compute expectation in case of continuous random variable, okay, and how to compute variance, right? So I believe you guys might have seen my previous lectures. So let us move ahead and discuss discuss some of like how to compute expectation, or you can say the variance for continuous uniform random variable, right? So expectation, okay, for continuous, okay, uniform random variable. Suppose uniform random variable is given, and you have to find okay, and the parameter is nothing but parameter of interest is nothing but a and b. So let me plot it. Suppose random variable is there, it takes the value, right, okay, between a and b. Okay, this is a range, so you can say range is going to be like this. Okay, this is a and this is b, and the height is going to be what? This is your density function, right? So it is going to be b minus a, right? B minus a. Okay, now how to find how I have written this constant as 1 by b minus a, because we want to maintain the area under the density function must be equal to 1. So now the question is, how do we find out the expectation? You know that expectation will lie between, if your random variable lie between a and b, so your expectation will also be lying between a and b. So directly you can see in case of uniform density function, okay, you can say that the expectation is going to be a plus b by 2. Directly you can find out, but let me use the formula here, right? So by definition, expectation of x is going to be integration minus infinity to infinity x f of x dx, right? So your density function is from where to where, guys? Your density function is from a to b, right? If your density function is from a to b, okay, so it's a simple calculation. Though in case of uniform continuous random variable, uniform density function, you don't have to use this expectation formula, like this kind of integral you don't have to do, right? But it's fine. Yeah. So this is nothing but from a to b, right? This is x, okay, and your density function is given as b minus a dx. Okay. Because at the end of the day you will get some formula in terms of b, a and b, so you have to remember the formula, okay, so that in the exam you don't have to compute this integral. Otherwise you have to solve this integral, okay, and it might waste your time. I know that you guys know how to solve integration, but still, okay. So remember the result. So it will be b minus a. Now you can integrate x with respect to dx. Since this is constant, so we have taken out of the integration, so it becomes x square by 2, right? A to b. Now you can put these limits, right? So if you put these limits, so it will be nothing but 1 by b minus a, right? And this is going to be, and you can also take 2 out, okay? So it is b square minus a square. So what is this, guys? This is nothing but 2 times b minus a, and you can open it b plus a and b minus a. So b minus a cancel, so it is a plus b by 2. So for uniform, okay, I think this result you have to remember, right? Okay, this is the expectation. Okay, so for, you can say the random variable which is uniform, uni, and the parameter is given as a and b, right? A and b. So the mean, or you can say the expectation, is going to be, mean or expectation is going to be, a plus b by 2. A plus b by 2, right? A plus b by 2, right? So you see this formula is okay, whether a and b, suppose you have got this kind of a density function minus 5 to 2. Okay, so if it is symmetric, let's say if it is symmetric, minus 5 and 5, so the mean is going to be 0 always, right? Because so what will be the mean here, right? So you can directly say that the mean, suppose this is the density function, okay, uniform density function. So the mean, or you can say the expectation of x, is going to be, now you can take this is a and this is b. So you have to just add it, 5 plus 2 by 2, which is nothing but, minus, you can say 3 by 2, which is minus 1.5, right? So that is your expectation is there, right? Negative 1.5 here. Okay, understand? So what we can do here is, sometimes what happens now, so it depends upon if x is negative here, right? If x is positive, okay, if random variable takes positive values, so your expectation will always be positive, that is for sure, because your density function is always positive, or you can say kind of non-negative, right? है ना? तो ये सिचुएशन आप याद रखना, डोंट गेट वॉन्टेड कि ओ हो नेगेटिव एक्सपेक्टेशन वी आर गेटिंग हियर, राइट? So I have also told you, right? Okay, if capital, the value random variable is greater than or equal to 0, right? So your expectation will also be greater than or equal to 0. This is important property, okay, that you have to remember. Okay? Because the your density function is always positive, right? मान लो तुम्हारा जो डेंसिटी फंक्शन है, इट इज सिमेट्रिकल अबाउट बाई एक्सिस, यू कैन से it is symmetrical about bi-axis, means suppose this is alpha and this is minus alpha, sorry, minus alpha and alpha. What is the mean here? Mean is this is symmetrical, okay, so mean is going to be minus alpha plus alpha by 2, which is 0. Okay, so the symmetrical has symmetrical distribution has the 0 mean. Okay, always remember these points. Okay, and how can you investigate the symmetry? You have to see the negative portion as well as the positive portion. Okay, so I believe this is fine for all. You guys can just okay, so now the question is, how do we compute variance? Computing variance, right? Computing variance for uniform density function, or you can also say continuous random variable, right? And it is random variable is uni in a and b, you can say. These are the parameters, right? So first of all, you can draw it quickly, right? So you can say that a and b. See, I'm taking x as positive only, a and b we are considering here positive. Okay, so this is 1 by b minus a. These are the style, the moment question you read it, right? So you have to quickly plot these things. Okay, don't waste your time, don't wait for somebody to tell you that, yeah, sketch, you have to sketch this density function, right? The moment you read the question, you should be able to plot this immediately. All the at least density function, you should be able to plot it. Don't write in terms of analytical expression, analytical formula. Just draw the graph. Okay, so that you can estimate now the mean. So here mean, you can directly say the mu or the kind of expectation is going to be a plus b by 2, right? Exactly at the mid it is gonna stay right here. This is the mean. But how to compute the that variance? So you know that I have told you one important useful formula to compute variance. I think you guys remember it. Okay, instead of using that the formula which is in terms of expectation of x minus mu ka whole square, and then use it, okay, what we can do here is we can simplify that formula and we'll get the useful formula, right? I mean, we can simplify the definition. So once you simplify the definition, you get this kind of formula for variance. Variance of x is nothing but what? This is the useful formula, you can say. Expectation of x square minus the expectation of x ka whole square. What is this expectation of x square, sir? Expectation of x square is nothing but it is a function of the random variable, right? So minus infinity to infinity x square f of x dx. Simple. So computing this is very simple. You know this guy, this is nothing but a plus b by 2 ka whole square. Right. This term you know already because you know the mean of the random variable x. So what is this, guys? You can say b minus a, and then it is going to be a to b x squared dx. Now you can just integrate this, so it is b minus a, and it is going to be x cube by 3 a to b. Okay, now you can plug these values, right? So 1 by 3 b minus a, right? Now it is b cube minus a cube, right? Now you can just open it, guys. Okay, so a cube minus b cube kya hota hai? What is the formula for that? A cube minus b cube, right? A cube minus b cube, simple formula, you can use it. Okay, understand? So you will get this. Okay, so you got this guy, right? Or as it is, you can keep as it is also, no problem is there, right? You just keep as it is. Next is what we can do here is we can plug these results into variance formula. Okay, so this is useful formula. Okay, remember to directly compute the variance. So variance of x is going to be, in the exam you don't have to derive for uniform random variables. See, for well-known random variables, okay, like exponential random variable, Laplacian, Gaussian, you will be able to directly compute the variance and expectation. You don't have to follow these integrals. Just I'm telling you for the sake of so that you can accept it, right, in your mind. Okay, so here 1 by 3 times b minus a, b cube minus a cube, right, minus, okay, expectation, that is a plus b ka whole square by 4, right? So if you're going to solve this, right, if you will solve this, okay, I think you guys can solve by yourself. Okay, so you are going to get the result as b minus a ka whole square, right, upon 12. So this is the variance formula. I'm not going to solve it, you guys can just solve it, okay, using this, okay, and this, understand? So b minus a whole square by 12 is the result for variance, right? So if someone is going to ask you, see, I'm just summarizing. Summary. Suppose random variable is a uniform random variable, okay, that is lying between a and b. So the expectation of x is going to be a plus b by 2, and the variance of x is going to be b minus a by 12, b minus a whole square by 12. Please remember these, okay, for your exam sake. Otherwise you have to, but make sure that the density function must be uniform. If density function is not constant, I mean over the interval, then you can't use this formula. Please remember that they are not valid for other type of Okay, and what is the standard deviation, sir? Standard deviation. Standard deviation sigma x, you can say, is going to be b minus a square root of 12, right? You know, square root of the variance is going to be the, okay, square root of variance is going to be the standard deviation. Okay, so I think this is clear. Yeah. And you know what is the expectation of DRV, uniform DRV? यूनिफॉर्म DRV, डिस्क्रीट रैंडम वेरिएबल का एक्सपेक्टेशन क्या होता है? सो आपको पता है कि मान लो तुम्हारे पास ये एक PMF दिया है लाइक दिस A B and sorry A plus 1 and the last is B. So you know this probability you can find out, that is nothing but B minus A plus 1, right? So now what is the expectation here? See, expectation is same, the definition of expected formula is same, that is A plus B by 2 only, right? Don't again try to find it. And the variance, I think you guys can recall, variance is going to be what? The variance is going to be B minus A, okay, and B minus A plus 2 by 12. Okay. B minus A plus 2 by 12, right? Okay. So this is for discrete random variable. Now A can be 0 as well. Yes, A can be 0 as well. Okay. समझ आया ना? So ये point आप याद रखो. Now you guys can start solving the question as well. So life will be far easier. So I have told you the mean, variance, okay, and definition also you know. Okay. Now we will talk about some different types of you can say different types of density function, right? Like we have discussed uniform, but uniform is not only the, okay, that was simplest, so I discussed. Now I'll talk about different types of density functions such as exponential density functions, right? Like we have discussed in discrete random variable, okay, various types of priority mass function, right? Okay, you can recall binomial distribution we discussed, okay, and Poisson we discussed, right? Because of the need, okay, because of the situation, geometric density function we have discussed, okay. Likewise we have to talk about exponential random variable, okay. Chalo. So we will talk about exponential random variable. So I think you guys can understand in case of uniform what are the thing that you have to remember, right? So let me again summarize uniform one, complete uniform you can say. So yeah. So you guys can just summarize it, right? So this is the summary of uniform. Okay. Already you have written, no problem. Okay, so this is, you see, this is the expectation alpha plus beta by 2, beta minus alpha by 2, and these are applicable only for, and you see this is CDF equation as well, right? CDF equation, okay, and this is okay, this is the PDF equation. Okay, CDF, I will tell you how to find CDF from PDF, right? CDF, you see, you can get PDF from CDF by differentiating, but how to get CDF from PDF? okay, मतलब डेंसिटी फंक्शन अगर दिया है तो CDF कैसे निकालोगे? CDF निकालने का मतलब है आपको डेफिनेशन अप्लाई करना है और इंटीग्रेट करना है फ्रॉम माइनस इन्फिनिटी टू एक्स, राइट? फ्रॉम माइनस इन्फिनिटी टू एक्स इंटीग्रेशन करना है, सिंपल. ओके, सो ये पॉइंट आप याद रखना, और that is just a summary that I have given you completely. Okay, and the plot, अगर आप प्लॉट करना चाहते हैं, and let's take alpha is 0 and beta is something, right? You can say beta is 1. So your plot is gonna look like this. This is the PDF graph. ये देखो, तो आप बोल सकते हो कि this is alpha and this is beta, right? So here this kind of a plot you will get. Okay, understand? So this is very simple to okay, so let me take one question as well before I start before I start solving telling you the. देखो एक क्वेश्चन करते हैं, बहुत ही इजी क्वेश्चन है. एग्जाम्पल, this question that you can see here. Okay, so this question I have taken from Stanford online, probability and statistics course, right? So you can understand that the language might be, now the language is quite easy since you know all the things, right? So can you solve this question and identify that what kind of situation you will, how you are going to model this situation? Yeah. So you are running to bus stop, okay? What you are doing, you are running to bus stop and you don't know exactly when the bus arrives. Okay? You believe all times between 2 to 2:30 are equally likely. Okay, equally likely means the equal chance is there, right? Equal likelihood is there. Okay, between this time the bus is going to arrive. You show up at 2:15. आप 2:15 में पहुंच जाते हो. So what is the probability that the wait time is gonna be less than p? What is the probability that the wait time is going to be less than p? So you can make assumption that this is going to be a uniform random variable situation, right? So you can quickly plot it. Okay, you can quickly plot it. So you can say that let t be the time, okay, in minutes after 2 p.m. that the bus arrives. Okay, because we think that all times are equally likely, so you can say that all times are equally likely, right? So the t, okay, you can say this is the situation that you have to think, right? Just I'm going to show you. So this is the situation. Okay, so let t be the time. You don't have to write in the notes all these things, right? You should be able to draw the graph. So after 2 p.m. the bus arrives. Okay, so you have to see everything up 2 to 2:30, right? So you can say 2 is the starting point. Okay, so t is going to be what? You can say that this is nothing but a density function. Okay, the random variable is t. Okay, variable is gonna be t, and this is 0 and this is 30. Okay, in minutes you can say, because this is uniform. So because we think that all times are equally likely in this range, okay, the probability that you wait 5 minutes is equal to the probability that the bus stop, okay, bus shows up between, you can say, 2:15 to 2:20, right? Understand? 2:15 to 2:20. So you can find out the probability now, right? So this is the density function that you have got, and it will be 1 by 30, right? 1 by 30. Now how to find this probability? The probability of this 15 to 20 is going to be nothing but 15 कहाँ पर है आप बोल सकते हो, this is 15 and this is 20, right? So this area, what is the gap here, guys? This is gap 5, and so 1 by 30 into 5, okay, that is nothing but 1 by 6. So answer for this question is going to be 1 by 6, right? Okay, 1 by 6. 1 by 6 you can say. But wow, why we have done directly like this, guys? Because probability is nothing but the area under the density function. And you can also use integration, but using integration, no need to compute integration here, right? Okay, no need to compute integration. It is directly doable since the density function is constant, right? And inside the integral, everything is constant. You can see also this. The wait under 5 minutes is nothing but you're going to wait between 15 to 20, you can say, right? Okay, 15 to 20. तो 15 to 20 आपने ले लिया एक इंटरवल, 5 मिनट का वेट है. Okay, and you see this is, so 1 by 6 if you divide. Okay, so how beautiful this example is. I think you guys understood, right? Okay, so you can also come up with the close form. जब इस तरह का सिचुएशन होगा ना, तो आप लोग क्लोज फॉर्म याद रखिए. ओके, बिटवीन ए टू बी अगर आपको प्रोबेबिलिटी निकालना है, ओके, फॉर क्विक कैलकुलेशन यू कैन से. Suppose uniform density function is given, right? Okay, you don't have to compute the integration, right? You can directly use this result. So we can come up with the closed form of the, for the probability that the uniform random variable x is in the range a to b, right? You can say like this. Okay. So अगर आपका x जो है, you know, if x is lying between, you can say that a to b, right? So directly you can just do it like this. Okay, मतलब आप समझ जाओ. So this is alpha, this is beta, right? And the height is 1 by beta minus alpha. And you have to find the probability between what? ठीक है, आपको यहाँ पर probability निकालना है. This is A and this is B. ये probability निकालना है. तो इसका distance कितना है सर? B minus A. And height कितना है सर? Height is 1 by beta minus alpha. So you know that the probability is nothing but the area. Area कितना हो जाएगा? B minus A upon B, beta minus alpha. Probability is nothing but the area. So please remember this for quick calculation. आपको फिर time waste नहीं होगा. जैसे मैंने आपको quick calculation करके दिखाया, right? I did the very quick calculation. Okay. So these are the problems that you can understand, right? Now we will talk about, guys, exponential density function. Okay, or we can also say that exponential distribution. Okay, it is very important distribution, right? Okay, we will talk about exponential density function. Okay, for continuous random variable, right? So what are the parameters? See, in case of uniform, there was alpha beta is the parameter. Here, what will be the parameter? So this is very important concept. Okay, this was asked in you know, in electronics and communication as well. This was asked in last year only, you know, in GATE 2024 for GATE data science and AI. ठीक है, तो ये important है, right? Okay, so what is this exponential distribution? See, exponential distribution, I think you might have gone through Poisson distribution, right? So in case of Poisson random variable, what we always do is we you know, like Poisson random variable measures what? That measures the number of events in a fixed amount of time, right? Okay, that you can recall. Okay. In Poisson random variable measures what? Poisson random variable measures the number of events in a fixed, okay, in a fixed amount of time. Okay, but exponential, there is a difference between exponential random variable as well as the Poisson, right? So there is a difference, right? So in case of Poisson, right, sorry, in case of exponential distribution measures the amount of time until the next event occurs. Until the next event occurs, there is nothing like fixed amount of time or fixed interval, right? So you guys have to remember these points, right? I mean, what is this exponential distribution, right? ये point आप याद रखना. So exponential distribution measures the amount of time, okay, amount of time until the next event occurs. It assumes that the event occurs via Poisson process. note that, okay, it assumes that the event occurs via Poisson process. Now note that this is different from the Poisson random variable, okay, which measures the number of events in a fixed number amount of time. ठीक है, तो ये अलग होता है, बट पॉइजन प्रोसेस की तरह ही हमें, मतलब जो इवेंट ऑकर होगा तो पॉइजन प्रोसेस की तरह रहेगा, बट दोनों में डिफरेंस आप देख सकते हो. It measures the amount of time until the next event occurs, and it measures the amount of, you can say, events in a fixed amount of time, right? Okay, so now what is the notation for expectation, sorry, what is the notation for uh, exponential random variable, right? Exponential random variable, ठीक है. So parameter is going to be what? देखो हर एक डिस्ट्रीब्यूशन या डेंसिटी फंक्शन या रैंडम वेरिएबल का एक पैरामीटर होता है. ठीक है, द पैरामीटर विल बी लैम्डा सर. ओके, एंड दिस लैम्डा हैज टू बी ग्रेटर देन 0. ओके, पॉजिटिव लैम्डा आई एम टॉकिंग अबाउट, राइट? ठीक है, lambda is a parameter here, right? Lambda is gonna be the parameter. So notation कैसा रहेगा सर, अगर हम notation की बात करते हैं? So notation is nothing but exponential of lambda. Okay, if it is written like this, you have to understand this is talking about exponential, exponential random variable, right? Lambda is the parameter for exponential random variable. ठीक है, lambda is a parameter for exponential random variable. Now how does this density function look like? Okay, that we have to understand. And this lambda takes the value like 0, 1, okay, constant average rate. Okay, and random variable will always take the positive real numbers. That also you have to remember, right? So how does our density function look like? So your density function, the former definition of density function for exponential random variable is going to be, remember this, lambda e raised to power minus lambda x, okay, for x greater than 0. Okay, for x greater than or equal to 0 you can say, and it will be 0 for x less than 0. Okay, so this is very important okay, result that you should know, right? I mean, formal definition for exponential random variable, right? So this is the exponential density function. Okay, exponential density function, you see lambda is there and in power also minus lambda x. Okay, and you have to make sure that the area under the density function, area, why we have multiplied this lambda here, so that the area under the density function. Now the question, people might ask you, why we have multiplied this lambda here and also here lambda is there, right? So you have to say that, sir, area under the density function must be equal to 1. That is the reason that lambda is multiplied. Okay, you can also note down these points, right? Suppose I write मान लो ऐसा लिखता हूं, f of x equal to k times e raised to power minus lambda x. Okay, x greater than 0 and it is 0, x less than 0, right? Suppose this is given. Now the question is, what is k, right? You can say find k. So now you should be able to find k, right? K is going, and though you don't have to compute integration here, right? You can directly say that, yeah, k is gonna be lambda only, right? But since you know that to find constant in the density function, right, area under the property you have to use, area under the density function or PDF must be equal to 1. So here minus infinity to infinity f of x dx equal to 1, right? Since this density function is starting from 0, so 0 to infinity it can go, right? K times e raised to power minus lambda x dx. to 1. Now you can solve this integral. So k times, e raised to power minus lambda x by minus lambda 0 to infinity. And this will give you ky lambda only, which is 1. So k is going to be lambda. Instead of doing this much, okay, what you can remember here is, if you are able to identify this is exponential density function, so this k should be lambda only, that's it. तो मतलब एग्जाम में आप और कुछ इंपॉर्टेंट इंटीग्रेशन रिजल्ट भी आप याद रख सकते हो. कोई अगर पूछता है 0 to infinity e raised to power minus lambda x है dx, so answer is going to be 1 by lambda. Okay, answer is going to be 1 by lambda. Please remember these results for your exam. ठीक है, quick results. Okay, so everything, see, my density function look like how? Density function is defined for positive random variable, right? Lambda e raised to power minus lambda, for lambda greater than, sorry, x greater than 0, but lambda has to be positive. That is important condition, right? And 0 for x less than 0. Now how does it look like? It is an exponentially decaying function. Exponentially decaying function like this. So it depends upon how fast and this decays, right? Okay, how fast this decays. See, this is faster decaying, right? And this is slower decays there, right? So it is for small lambda, and if it is for large lambda, you can say. If the lambda is larger, right? If the lambda is larger, it is going to decay faster. This is at 0, the density function is lambda only. You can plot it, okay? So if this is x, so if the lambda is small, it is going to decay slower only, right? Okay, please remember this. Okay, this is important. Okay, so I think this is clear for all, right? So you guys can just understand these points. Fine. So this is going to be your expectation. Okay. Fine. Not expectation, the graph. Okay, so let me compute the expectation as well, but before that, some important result you have to remember. Suppose someone is going to ask you what is e raised to power ax dx. What is the integration of e raised to power ax dx? So it is going to be 1 by a e raised to power ax. Okay. 1 by a e raised to power ax. Okay, upon a. Understand? I think this is clear for all, right? So suppose you have to find, suppose you have got the density function. You have example I'm just taking. Suppose you have got the density function lambda e raised to power minus lambda for x greater than 0, right? So if you want to find probability of x greater than a, what is this? Probability of x greater than a means you have to integrate from a to x, sorry, a to infinity, right? A to infinity, because you have to integrate, you have to find the area. Probability means area, a to infinity, because x can take the lower bound a and the upper it can go to and this is e raised to power lambda times e raised to power minus lambda x dx. Now what is the result of this? What is the result of that, right? So you should know this, right? You can take lambda common. Okay, now you have to integrate a to infinity lambda e raised to power minus lambda x dx. Now you should know this result, right? E raised to power ax dx is going to be e raised to power ax by a. Simply you have to replace a to minus lambda. That's it. So here if you replace, okay, if you replace this lambda, minus lambda x upon minus lambda a to infinity. Okay, so what is the result here, guys? If you compute this result, right, so you're going to get e raised to power, this is a, okay? Please remember that, e raised to power minus lambda a. Simple it is, okay? E raised to power minus lambda a you are going to get, okay? Because e raised to power minus infinity is 0. Huh? So the result for this is going to be e raised to power minus lambda. Simple answer. This is a simple computation that I have done, right? And how do we find out the how do we find out the expectation of the exponential? Expectation and the variance for random variable expectation exponential of lambda. ठीक है, कैसे निकालेंगे? देखो याद रखना, एक्सपेक्टेशन ऑफ एक्स इज बाय डेफिनेशन क्या होता है? माइनस इन्फिनिटी टू इन्फिनिटी एक्स एफ ऑफ एक्स डी एक्स. ठीक है, so if you plug, see your density function is defined for positive, okay, like from starting from 0 to it can go to infinity. X, what is this density function? That is nothing but lambda times e raised to power lambda x dx. So if you solve this, okay, if you're going to solve this, okay, अगर आप इसको solve करते हो इंटीग्रेशन को, I'm not going to solve it but you have to solve it, right? So the result you can directly remember is 1 by lambda, right? 1 by lambda is the result, okay? So expectation of the exponential density function is going to be 1 by lambda. Okay, and if you want to find the variance, so variance is nothing but from the formula x square minus the expectation of x ka whole square. But you have to find this, you know this already, but what is this? Expectation of x square is going to be minus infinity to infinity. You can use the expected value rule, x square f of x dx, right? Since your density function is positive, right, I mean it is defined for positive x, so it is starting from 0 to infinity. It can go like random variable can take the value, okay, up to infinite x square lambda e raised to power minus lambda x dx. Now again you have to solve this integral, right? So you can say lambda, you can take common, 0 to infinity x square e raised to power minus lambda x dx. So guys, remember that for this also the result is going to be 1 by lambda square. 1 by lambda square, okay? No, not 1 by, 2 by, 2 by, 2 by, sorry, 2 by lambda square, okay? 2 by lambda square, okay? ठीक है, for exponential distribution, ठीक है? So what is the variance now? You can find variance. So 2 by lambda square minus 1 by lambda square. So it is going to be 1 by lambda square only. Okay? So the variance for exponential distribution is 1 by lambda square. ये आंसर आएगा. But how to compute this integral? Please understand that, okay? Because there is two functions are there, and we are integrating two functions, okay? U dot v. Fine. So I think this is clear for all, right? I mean, you can do it, okay? So this is all about density functions, okay, and their expectation. So expectation, I mean, the exponential density function is very important, okay? Very very important. ठीक है, देखो अगर मान लो तुम्हारे पास डेंसिटी फंक्शन गिवन है, राइट? एक्सपोनेंशियल density function is, you know, right, that is f of x is equal to lambda e raised to power minus lambda x and x greater than 0 and 0 otherwise. Okay, see, you should write again and again these things, okay, so that you can always keep in your mind, right? So suppose they are asking what is their CDF. So CDF is nothing but the probability x less than small x. Okay, x less than small x. So if you want to integrate this guy, from minus infinity to x, okay. Okay, I'm just applying definition, right? So lower limit is going to be 0 only, right? So you can say 0 to x lambda e raised to power minus lambda x dx. Now you can take lambda out, right? So what is this? Right? It is going to be e raised to power minus lambda x upon minus lambda, and if you put 0 to x, right? So lambda gets cancelled here. You will get 1 minus e raised to power minus lambda x only. This is the answer, right? Okay. So the CDF for exponential random variable is gonna be what? 1 minus e raised to power minus lambda x. Okay. Okay, for x greater than or equal to 0 and lambda greater than 0. ये सब आप याद रखो, right? These are the results that you have to always keep in mind. ठीक है? I'm just going to show you everything in you can say in summary. So for exponential random variable, right? What are the things that you have to remember, right? So in gate examination, you don't have to waste much time on computing. Okay. So you see this this PDF. I mean this slide. Okay. So exponential random variable. For exponential random variable, what is the density function? What is the notation first of all, and the description, the time until next event if the event occurred with a constant mean rate. Okay, that lambda is gonna be the mean rate, and B, they occur independently of the time since last event. Okay, matlab exponential random variable has also got the memorylessness property. Okay, memorylessness. Okay, memorylessness property. Okay, memorylessness property. Understand? Means whatever happened in the past is not going to affect your future events. Okay? Just like I talked about geometric, random variable, right? Geometric. There was also memorylessness property. Understand? So parameters is nothing but your lambda only, that is mean rate, the constant average rate you can say. And support is gonna be, you see, x is r plus. R plus means all the positive numbers, right? Real numbers. And the PDF equation is this. CDF equation is this, right? Expectation आप देख लो ये है 1 by lambda. Variance is 1 by lambda square. Okay, so these are the things. And if you take lambda 5, and if you want to draw the PDF, right? So how does your PDF look like? Take lambda equal to 5. Okay. This is the PDF that, okay. So the PDF lambda is a parameter is going to be 5. So this is the probability, and this is going to be, you see, okay, as long as the lambda increases, right? So it will decay faster. Okay. So this is how your exponential density function look like. Okay. So exponential density function is a great example of, you can say, continuous distribution where cumulative distribution function is much easier to work. Okay. Okay. And it allows you to answer the probability question without using integration. ये भी पॉइंट आप याद रखना. Okay, so as you can see here, exponential distribution is a great example of continuous distribution where cumulative distribution function is much easier to work, right? You might have seen, 1 minus e raised to 1 minus lambda x. तो मान लो तुम्हें निकालना है एफ एक्स टू, दैट इज नथिंग बट प्रोबेबिलिटी एक्स लेस देन टू, विच इज नथिंग बट 1 माइनस ई रेज्ड टू पावर माइनस लेमडा इंटू टू. लेमडा की वैल्यू दी रहेगी तो आंसर आ जाएगा, राइट? So it is very simple. You don't have to integrate here. Needless to integrate. Okay, directly you can plug here. Okay, the answers. ठीक है, या कि density function is given, right? If density function is given and you have to compute, like suppose they are asking what is the probability of x greater than 2. So you can write this as 1 minus probability of x less than 2, right? So this is 1 minus f of x2. 1 minus e raised to lambda times 2. ये तो डायरेक्ट आ गया, 1 1 कैंसिल हो जाएगा, e raised to minus 2 lambda. Okay, lambda की वैल्यू गिवन रहेगा तो आंसर आ जाएगा, राइट? So let me take one problem as well, right? Let me take one problem, okay, and so that you guys can experience, yes, this is the problem. Again, I'm taking this problem from Stanford online course, right? So this problem was given here, so can you take a look here, read it, and try to understand what kind of distribution, what kind of how do we model this situation, right? So the question here is based on the historical data from USGS, earthquake of magnitude 8 plus happen in a certain location at the rate, ये lambda दिया है, at the rate of 0.002 per year. Earthquakes are known to occur via poison process. अब ये बोल दिया ना, via poison process earthquake occur होता है. What is the probability of the major earthquake in the next 4 years? In the next 4 years, right? Okay, so what we can do here is we can model, okay, situations, right? So they are asking basically what is the probability of the major earthquake in the next 4 years? Okay. So basically they are asking this, you read this point. So let by be the years, okay, until the next major earthquake occurs, okay, until the next major earthquake, okay, because by measures time until the next event, it fits the description of the exponential random variable, okay, by equal to this, and the parameter is given as 0. That is the rate, okay, per year. The question is asking what is the probability by less than 2. तो by less than 2 का मतलब क्या होता है? fx4 आपको निकालना है, that is you know CDF equation e raised to power minus lambda into 4. So 1 minus e raised to power minus lambda is given as 0.002 into 4. So if you solve this guy, okay, if you solve this guy, so you will get around 0.008 approximately. This is the probability you got. So see, I haven't done any sort of integration or something, right? Okay, you don't have to do integration. So okay, so your answers is this. I have also solved, but so CDF measures this probability directly, okay, you don't have to go for integration. ठीक है? So it is possible to answer this question using PDF. It will not require, you know, an integral. Okay. So see, exponential is also memoryless. There is a memorylessness property, right? Memorylessness property is there in case of exponential. Okay. Since they are independent of the past events, whatever future event has to happen via this exponential process, the Poisson process. Past event is not going to affect your future events, right? Okay, so that is the very important property in case of exponential. Okay, so exponential is also a memoryless. Yeah. this. So exponential is memoryless, guys. Okay. One way to gain intuition for what is meant by Poisson process is through the proof that exponential distribution is memoryless. ठीक है. जैसे मैंने बोला ना कि this the exponential is via understood via Poisson process. Okay. So what is the meaning of Poisson process here, right? So you have to understand that exponential distribution is memoryless. What is the meaning of that? The meaning of that, the occurrence, or you can say the lack of occurrence of events in the past does not change our belief as to how long until the next occurrence. Okay. And this can be stated formally. Okay, if x is an exponential random variable, so for an interval of time until the start s and the preceding query interval of time t. Okay, so you can say that the probability of x greater than s plus t, given that x is greater than s, right, is going to be equal to, okay, they are independent situation, guys. X is greater than t only. Conditional, this is a conditional probability, right? But since these two events are independent, okay, some events has already started, right, and some events are going to happen after some amount of time, you can say, right? You can understand like this. This is the situation. Suppose event has to happen, right? So something has already happened here. Okay, it started, and after what time something has to happen here. Suppose this is s and this is s plus t. So probability of x is greater than s plus t. Okay, given that x, which is nothing but probability of x greater than t only. Okay, so how to compute this, that I'm just going to paste here and you can understand that. Okay, so this is the situation, and then from definition of conditional probability, okay, this is the joint and total definition of conditional probability. Here also they have mentioned the comment, and then see, because x greater than s plus t implies x greater than s only, right? Okay, so, and this is definition of CDF we have applied, and then CDF of exponential definition you have applied here, and then we can simplify and you will get the result here. Okay, that is definition of CDF. Khatam. Okay. Oh. Okay, so I think these points are okay, right? You guys can just note down and you will get the result. Understand? Fine. Now, the very important distribution that I'll talk about is the normal distribution, guys. Okay. Normal distribution. So this is one of the very important concept that I have discussed, right? So please remember mean expectation. Okay. और गेट में क्वेश्चन भी आया था, दैट क्वेश्चन आई कैन डायरेक्टली टेक हियर. गेट, okay, let me show you that question, and in the next session only I will talk normal density function and all. ठीक है, so I can take those questions which were asked in gate 24. Okay, just wait. So whatever question, whatever concept we are discussing, directly question will be asked and you will not take much time to solve the question, right? Remember this. Yeah, so मेरे क्लास में यही होता है बेसिकली, ठीक है। थोड़ा सा यू हैव टू लर्न ऑल दीज, व्हाट इज दिस मेमोरी लेस। मेमोरी लेस का मतलब क्या है, सोचो। You have to become also memory less, okay? Suppose you are preparing gate from many years. So in the past, whatever situation happened, it should not affect your current situation, right? You should not feel like, oh, you can't crack gate after attending Dheeraj sir class now. See, you were attending somebody's class, right? But now you are attending Dheeraj sir class. So there is a high probability that you can crack it. ठीक है, ये सब मत सोचा करो। So just let me find that question and solve it for you. Just 1 minute, yeah. मिल गया. Okay. You see how easy question was, right? And you will be able to identify that, yeah, this is exponent. This question was asked in GATE 2024 data science and AI, right? And directly from my classroom only, you can see exact question from my classroom. Okay. So you see the x be the random variable exponentially distributed with the parameter. See the language. अगर मान लो मैं प्योर हिंदी में आपको पढ़ाऊं, राइट, तो कुछ समझ में नहीं आएगा। देखो क्वेश्चन भी मैच कर रहा है विथ पैरामीटर, द वर्ड पैरामीटर लेमडा। ओके, लेमडा इज नथिंग बट काइंड ऑफ कांस्टेंट रेट, राइट, रेट which is greater than 0. The probability density function is given here. See, notation and all, everything is matching, right? Now what they have given here is, if this is given, okay, if they have given 5 expectation of x equal to variance of x, okay, they have given this, and this is for 2-mark question. So how much time you are going to spend? Let's see. Indicate expectation variance of x respect. What is the value of lambda they are asking? Very simple question. See, expectation is, expectation, that is 5 by 1 by lambda. 1 by lambda is the expectation, is equal to variance. Variance is going to be 1 by lambda square, right? You can recall it. I think I have told you. See, यहाँ पर मैंने बताया है ना, देखो ये वेरिएंस, ये एक्सपेक्टेशन है, ये वेरिएंस है। यू सी 10 सेकंड क्वेश्चन, राइट? तो इसको आप लेमडा लेमडा कैंसिल कर दो भाई। सो लेमडा यू कैन से 1 बाई 5, आई थिंक, या 5 by lambda is equal to 1 by lambda square, right? Yes. So इसका आंसर आ गया कि नहीं आ गया? देखो, up to 1 decimal you have to find. So it is nothing but 0 point something, 0.2, yeah? So answer will be 0.2. So कितना लगा? 10 second. Okay. So we'll meet in the next class and we will discuss नॉर्मल डिस्ट्रीब्यूशन। ये बहुत इंपॉर्टेंट है सर, ये यही तो मेन है पूरा। योर इंटायर स्टैटिस्टिक्स रन अराउंड दिस। ओके, सो विल मीट इन द नेक्स्ट सेशन एंड we'll talk about this. Okay, thank you, keep learning.